Thank you for coming along today, and thanks to the Royal Scottish Geographical Society for inviting me as one of your Inspiring People at Home series of talks. I will hopefully show you today some examples of application of discipline knowledge of geography, biogeography, geology and soil science, followed by criminal and civil law. So what is soil? Soil is the living bridge between rock and life, as James Hutton said. I'm based at the James Hutton Institute, which in 2011 was formed by the merger of the Macaulay Land Use Research Institute and the Scottish Crop Research Institute. James Hutton was a Scottish geologist, experimental agriculturalist, chemist and naturalist. He was often referred to as the father of modern geology. His work played a key role in establishing geology as a modern science. Hutton developed the theory that geological features were not static, but underwent perpetual transformation over long periods of time. He argued that Earth's remote history can be inferred from evidence in present-day rocks. It is that concept of determining what happened in the past from earth science that I take into the science of forensic soil science. Charles Kellogg, soil scientist and Chief of Bureau for Chemistry and Soils at the USDA, said that essentially all life depends on the soil, and that each soil has its own history, like a river, a mountain, a forest, or any natural thing. Its present condition is due to the influences of many things and events of the past. With an understanding of what examination and analysis of soil and its related material can tell us about that past, about where it came from, and present as a silent witness as to where someone had been and when and where an event had occurred. And soil varies in so many ways across a landscape. Soil has the properties of an ideal trace evidence. It's highly individualistic. It has a high probability of transfer and retention. It's often so small that it's nearly invisible, can be quickly collected, separated, concentrated, analysed, and the merest traces can be characterised, and it's able to be compared with a computerised database. However, forensic soil science is by no means new. According to legend, an examination of soil and rock fragments found contained within the hooves of horses assisted Roman soldiers in locating the camp of the enemy. The famous zoologist and correspondent of Humboldt and Darwin, Professor Erberg, carried out a classic investigation of substituted materials. This was described in the Scientific American in 1856. As one of the Prussian railroads, a barrel which should have contained silver coins was found on arrival to have been emptied of its contents and was refilled with sand. On being consulted on the subject, Erberg sent for samples of sand from all the stations along the different railway, and by means of microscopy he identified the station from where the sand must have been taken from. The station once identified, it was then not difficult to hit upon the culprit in the small number of employees on duty there. Substitution continues to this day as a common criminal practice, often using geological materials due to their weight, size and negligible cost as replacement materials. And another example is the substitution of whisky bottles, the whisky in the boxes being exported from ship from Scotland. On arrival at the final destination, the bottles had been replaced by granite chips. The ship had docked at a number of ports in different countries en route. The granite was a distinctive type that was only found in one of the countries. A visit to the port established a pile of similar chips in a yard close to where the ship had been moored. The dock workers had access to both the dock and the ship, and they were questioned, and the guilty parties admit their crime. However, the whisky was sadly never recovered. Soil is an ideal trace evidence material. It covers most of the Earth's surface, and we have to travel by foot or cycle or vehicle and customarily come into contact with that material. It's often unconsolidated, it's wet, it's got organic material, and therefore it's readily transferable. If we take vehicles, for example, the soil from the wheel arches, it's often preserved in layers, and what we can do is recover the individual layers into sample vials and look at potential multiple places of contact. Soils from brake pedals or tyres can link a suspect to a potential location, or indeed exclude them from being at that location. Samples taken from the boot of a vehicle can indicate where digging had taken place. For example, soil can fall off a spade or a tool. They may be found and various layers can be sampled and indicate multiple locations of digging. Multiple soil trace evidence material on objects can indicate that there's been multiple burial locations. It can also help indicate potential entry route or exit route of a perpetrator. The vegetation or the conditions of the vegetation can also tell us that there has been potentially something laying on the surface or buried at a particular place. And we can use organic indicators as telling us likely times of when something had occurred. But now we can use very small amounts of material barely seen with the naked eye. Samples from clothing can be sampled. Samples from fingernails can be analysed and can relate back to individual locations where someone's been. And also material that's come in the filter of a washing machine, that can be extracted and the mineral composition of that analysed and compared with that at a particular location. Footwear is one of the most common evidence types that we would get sent in as productions, and that also can be sampled in terms of the multiple layers that appear on the sole or on the side of an item of footwear, and an analysis can be carried out on these separate places. And vegetation is often associated with that soil, and that too gives us clues as to what type of vegetation is growing at a particular location. And that can be paired direct comparison with that at the location of interest. But whatever the exhibit that we are presented with, whichever that questioned item is, it's always teamwork. The multiple experts in the team, from the soil scientists, the geographers, the geologists, the archaeologists, the pathologists, taphonomists, the multiple range of experts with different combination of people working on different cases depending on the investigative question that the SIO has asked the scientists to assist with. The questions of who was involved, that is a domain of the forensic biologist. But the questions that the forensic soil scientist, forensic geographer might assist with are, what happened? Work out, help where it happened, the big question, where in geography. But also help answer, how did it happen? What was the sequence of events that led to this particular scenario? And when did it happen? Again, there can be some clues that can come from decomposition studies that can help ascertain the likely time window of when an event occurred. And ultimately, we all want to know, why did it happen? So to help us answer these questions, we're very fortunate in Scotland in having here at the James Hutton Institute a soil archive covering a systematic soil survey of Scotland from 1934, sampled in 1978 to 87 and revisited in 2007 to 2009. We've samples from long-term experiments, and we've samples from across the whole of Scotland of the very soil surface taken in the 2007 to 9 sampling. We also have a soil DNA archive with over 1,500 samples and around 50,000 air-dry samples for potentially comparing with a question sample if we do not know the origin of that sample. And we have maps and digital databases to which we can compare the results of the question samples that we examine. Soil can be used within a search frame within a geographical information system. The soil or vegetation on or from a vehicle or footwear may provide that clue as to where that particular search location is best prioritised. The geoforensic data uses the soil data, plus vegetation, topography and accessibility, all of those building the layers so that we are then prioritising the information from parent material, soil characteristics, geological characteristics, land use characteristics, along with police intelligence information, such as the suspect's sphere of activity, the locality of physical evidence, the last known position, or the maximum likely distance travelled. It's that combination of information that can help narrow down and produce that geographical information system. We can query information at a particular location. We can combine that different type of data, graphical, analytical, and derive the priority areas of searching. And we can produce hard maps that can go with that to be provided to the SIO to help locate and help search activities. We can work at a multiple range of scales, from national or regional down to specific local areas, town, forest or particular waterways, for example. We were asked by BBC 4 to see if we could identify the soil on the footwear of Gabrielle Weston, the presenter. So we received this Wellington boot and we looked at the sample, we examined it, we analysed it using a range of inorganic and organic methods. And using that information, we were first able to exclude areas. So first of all, excluded that it was not from an urban area. Then we could exclude it certainly did not have the fibrous characteristics of peat. We could exclude coniferous forests and woodlands because it did not have the characteristics of a coniferous woodland, and we knew it wasn't an arable soil. So the next stage was that of including the characteristics that we could measure on these soils. We included characteristics of the pH of the soil, the colour, the carbon content, and the fact that we knew that it was from a deciduous woodland. We combined that with accessibility and identified the areas very close to where Gabrielle stood. And when she came into our offices for the big reveal, we identified an area at Muddock Country Park, and indeed she confirmed that we had got a location that was 500 metres from the path that she walked. We were then asked, as often media get interested in these kind of whodunit scenarios and where did they walk, we were asked to look at, for the BBC One show. Again, it was a Wellington boot with no other information but here's a boot, here's soil, where in the whole of Scotland could it have come from? And in real case scenarios, normally we're giving more information than just anywhere in Scotland. Usually working with the SIO, the investigating team, that there's other information, as I said earlier, that we can couple together with the natural information that we can adduce from looking at the soil and vegetation on the item of footwear.
Well, we interview a lot of experts on this show, but I don't think any of them have been put on the spot quite so much by our presenters as much as Professor Lorna Dawson.
Yes, she put her reputation as one of our finest forensic scientists on the line for Marty, so let's see if she'll regret it.
When it comes to crime scene investigations, cases can often hinge on tiny microscopic details, like hairs, saliva or blood. But what if the only evidence of a crime is mud? Surprisingly, evidence from mud has been used to link dozens of murderers to the scenes of their crimes. So how precise can it be? I've been for a walk somewhere in Scotland's 30,000 square miles, and I'm setting forensic scientists a challenge. Can they put me in a specific place using only the mud on my boots? The exact location is hidden in this envelope. I'm taking my sealed envelope and muddy boot to the James Hutton Institute in Aberdeen, and to Professor Lorna Dawson and her team, the UK's top forensic soil scientists.
The clues are held within that soil. Those can tell us where that person has stood. So we're looking at fragments of vegetation. We're looking for hairs and fibres to compare it with soil at a crime scene.
So how close can Lorna get to pinpointing where I've been walking? First, a simple visual inspection can reveal quite a lot.
It tells us, because there's a very, very small proportion of sand in this sample, that it's not come from a beach environment, it's not come from a riverbed type environment, it's not got fibrous peat in it, so we know that you've not likely walked on a peatland.
Looking at the soil, Lorna's expert eye immediately rules out parts of Scotland I definitely haven't been. The next step is to identify the underlying geology of the area I was walking in. And for that, Professor Steve Hillier uses X-ray crystallography.
Soils can have a very strong relationship to the rock type underneath them, so-called parent material.
Scotland sits on dozens of slightly different rock types, clearly marked on geological maps. By using X-ray crystallography to calculate the exact mineral makeup of my mud, Steve can work out what kind of rock lies underneath.
This blue one here is a zeolite, and we've also got a mineral called a pyroxene. So my initial thought straight away is this must come from some kind of igneous rock.
Knowing that my mud sat on top of igneous or volcanic rock means Steve can start to narrow down likely locations.
It matches very closely with the kind of igneous rocks that you find around Edinburgh, Stirling.
But also hidden in the soil is biological evidence, far too small to be seen by the naked eye. Pollen specialist Ilse Kamerling is using a powerful microscope to look at the soil in minute detail.
Some cereal pollen, which suggests a meadow or a field probably surrounded by an area where cereals will be cultivated.
Okay, what else?
Spores that are produced by fungi that grow on the dung of animals.
Finally, Lorna cross-references the composition of my sample to a huge database of 30,000 soils from across Scotland. She's now ready to reveal her results, starting by eliminating where she thinks I haven't been. Lorna, tell me about your results.
So the dark coloured areas on the map are those that are sandy, so you did not go there.
I wasn't there, okay.
You didn't go to peatland areas. You were not on an arable farm.
Right.
We're excluding all the areas in Scotland where there's conifers growing. Then we looked at the carbon content of the soil. We add all those different layers in, and it
doesn't leave much, does it?
No.
Having ruled out most of Scotland, we're down to a scattered collection of possible locations. Next, she looks at which of these remaining areas match the rock profile from Steve's X-ray crystallography.
So one of the main characteristics of the where question, where you were, is the soil, the geology, the underlying bedrock. But one of the areas that we thought most closely compared was at Dalmeny Estate.
That's your final answer. Well, in here is the actual answer.
Okay.
I'm looking quite nervous. So, here it is, and the answer is the Dalmeny Estate, South
fantastic.
Queensferry. You were absolutely bang on. I could have been anywhere in Scotland, and yet Lorna pinpointed my location to within a couple of 100 metres out of 30,000 square miles. That's some pretty astonishing science.
So when we requested to attend to a scene, arriving at the scene, the first priority when the body has been discovered is to secure that scene and to make sure that a common approach path is determined. And again, the geographical information of where someone likely walked, any impact on surrounding vegetation, that helps identify where to avoid in sampling, where to avoid in people walking onto the scene, because these could be areas where it's important to take contact trace point samples. When you're sampling around the victim, the priority areas are fingernails. For example, as I said earlier, you can identify that whether there had been a previous location where the victim had been. Areas around the footwear, so are there multiple sources of soil on the boots? Where is the soil on the boots? Is it on the soles? Is it on the uppers? Is it on the clothing of the victim? Around the head of the victim? Are there soil particles? Is there vegetation embedded in the hair or the nasal passages or the ears? All those potentially can give evidence of what happened. and also any objects at the scene if they carry with them soil, pollen and items of vegetation. That can help the investigator work out what happened. When we're sampling for soil, we would also look for contact points, places where there were features such as footwear or tyre marks. Those are photographed and cast by the scene crime officer, and soil samples can be recovered from or nearby to those particular locations, because these give us clues that those are places where a vehicle or a person may have stood. We sample that very surface contact material, we collect it wearing full PPE, collect it and retain it within an evidence bag. These productions are packaged and submitted then to our laboratories here at the James Hutton for analysis and to protect that sample. And on receipt, that packaging's checked to ensure that it's intact and completely sealed for chain of custody. And all those things are important because this is soil science working within the criminal justice system. The soil itself is so diverse and so variable that we focus on a range of attributes of soil involving the inorganic and the organic, and also the biological components such as leaf material, individual plant material or animals that are in the individual samples. We've got at our fingertips a range of methods that can be applied to these question samples that come in from footwear, vehicles or tools, and we apply the different techniques depending on the size and condition of the samples. If we get a question sample submitted by the police, and this sample, this production, we examine it, and here it's a suspect footwear, and we are asked by the police, where has that person recently stood or walked? We are able to compare that with our database that we hold, the digital database, and narrow it down, comparing the attributes that we've ascertained from analysis of that sample. And here in this scenario, we're able to say that the soil has come from an area of car parking or lay-by type material. So we lay that layer on the GIS, and then on top of it, we know the pH. We know the pH is between 5.6 and 5.7. So then we can go to the areas that share those attributes and lay on top of that the fact that we know it's a coniferous woodland. Again, that sets a layer, so it takes us closer and closer to potentially 3 locations that share those attributes. Narrowing down even closer still, we can take the police to one particular location that has that distinctive combination of soil and vegetation characteristics. And it's there that the police will then search for further information as to where the person has been located. So looking at that sole of that footwear of the suspect, we can say that that person had stood at the top of that riverside. We also can say that they stood in that coniferous woodland. While the soil on the victim's shoe, that did not have any of the characteristics of the location where she was found. But on the other hand, it did have the characteristics of that coniferous woodland. So this allows the police to work out what happened. Indeed, she'd been murdered in the coniferous woodland where the accused and her had struggled, and he had dumped her in the deciduous woodland where she was found by the dog walker. Communication of geographical information, soil information, is vitally important. Whoever we are speaking to, whether that be policymakers, other scientists, students, practitioners, or indeed anyone within the criminal justice system. We have to work with care, caution and clarity. Key attributes of what the forensic scientist should be, whether at the crime scene, in the laboratory or in court. We forget what the fictional counterparts seem to take as speed, style and certainty. We certainly don't have any of those. So I've worked with crime authors over the years, and I'm going to take you on a little tour now of some of the locations where we've got scenarios, fictional scenarios, of where crime has taken place. Starting in the Northern Isles, working on the Shetland serial with Anne Cleeves, and also Lynn Anderson with her novel None But the Dead. Lynn, in her novel, talked about the principles of secondary transfer. She said, the same classification of soil was found in the grooves of the waterlogged boots. Yet the pedals of his jeep were encrusted with shell sand, suggesting he wasn't the person who drove the jeep onto Cata sand. The soil evidence suggested she had made her way through the former camp, en route to the place. There was no forensic evidence to show she'd gone by way of the beach or crossed a different soil formation. And then now to Aberdeen. And here we've got the great Stuart McBride, who's written many of his novels based on Aberdeenshire and Aberdeen City. And in one of his novels, he talked about exactly the principles of multiple sources on an object. And here he used a spade. And here in Grampian, he noted there's two different layers on the tools. The one on top is a peaty podzol, but the one underneath is a peaty clay. So, deducing from that, the Lairhill soil got stuck to the shovel first, then to the stuff from Dufftown. Again, showing the principles of multiple layers of information that can help the police work out where someone had dug. Lynn Anderson said, our sample contains soil information to reflect such a location, evidence of mine workings, and feral animal faeces, also in the vicinity of a portion of the disused Kelvin Grove Park Railway Tunnel. Dr. Mackey, my pseudonym, said, although I believe an attempt has been made to wipe the soul prior to the most recent layer, as with blood deposits, perpetrators rarely realise the level to which we can both identify and analyse the evidence. And Lynn here brings in another vitally important aspect, that we can look and characterise urban soils, anthropogenic soils, as well as naturally developed pedological soils. And we can look at aspects such as faeces and metal material, which help provide those clues as to where someone had been. In Edinburgh, Ian Rankin, in his book In a House of Lies, used the principle of forensic soil science. He said, she scooped up some of the rich, dark soil, crumbling it between her fingers. You can learn a lot from bugs. Some insects frequent particular environments. I'm just not convinced that this car lay in this gully for 12 years. Again, this is bringing in the principle of the botanical and the entomological information that can help work out how long an object has been in a particular location. In his book he said, the Met Office had made room for visitors, including the soil specialist from the James Hutton Institute in Aberdeen, Professor Lee Ann Ingalls. She was in her early 40s, thank you Ian, with long brown hair parted and tucked behind one ear. She'd come armed with data. She explained to the room about soil fingerprints and the record she had compiled from hundreds of samples. A few crumbs on the sole of a shoe or embedded in a tyre could pinpoint where that shoe or tyre had recently been. He said when I asked him about the use of forensic evidence in his novels, he said, I began writing the novel knowing I would have a car that was a murder scene, but also had been undiscovered for many years. I knew forensic investigators would check it thoroughly. Part of that would involve a check of the dirt found on the tyres. The dirt gave clues that the car had been hidden somewhere far from the location where it was discovered. This gave me an extra puzzle for the reader and my detective to solve. Science and technology are crucial to the investigation of crime. Readers know this, so authors should take account of this. Anne Cleeves in The Moth Catcher, she gave a testimonial that through an understanding of the expertise, she writes with more confidence. She's learnt that every handful of soil has its own story to tell, and that, of course, feeds into the plot. And that was especially useful in The Mothcatcher, a Vera story. And Val McDermott, she really stressed about the importance of place. She said that the best crime novels are like a three-legged stool. They depend on character, story and setting. And don't underestimate the power of setting. If you write about place in a way that for someone who knows the place, they're obviously there with you, when they trust you with everything else you're telling them. I think we, as forensic experts in court, can take a leaf from these crime writers' books, in that we need to communicate with the jury, with the general public, so that we communicate about place and instill a sense of trust, so that they can understand and interpret the information that is being put before them. To conclude, here is a word cloud that ends on the key messages that jurors feel about the communication and presentation of geoscience in court. You can see how communication, a sense of place, engagement, integrity and honesty are vitally important. So are the use of good graphics, photographs and including maps. Thank you for listening to my talk today, and thanks to all the many people who have allowed this to take place today. And hopefully we can all help in our own small way to make Scotland and the world a better and safer place to live in, despite our many external threats, which we will overcome with collaboration and cooperation, not least with the principles of spatial information, geography and soils. These are truly transdisciplinary subjects. Thank you for listening.